back to the class. So we have 7 exponent x minus 4 exponent x equals 33. Okay. All right. So this is an exponential equation. Okay. And if you look at it carefully, 7 exponent x minus 4 exponent x is an increasing function. Okay. Now, in the real number system, if 7 over 7 exponent x minus 4 exponent x is an increasing function, then it can equal 33 only once. Okay. All right. So we are looking for the resolution for the equation. All right, so you say 7 exponent x minus 4 exponent x equals 33. All right, so you're going to have 7 exponent x. Now, 4 can be written as 2 exponent 2. All right. Okay, so here we're going to apply the power of a power rule of indices. Okay, so a exponent m, okay, times c is the same as a exponent c times m. So we are changing the positions of the exponents. So you have 7 exponent x minus 2 exponent x all squared equals 33. All right, now any number or anything times 1 is the thing itself. Because of that, we can write 7 exponent x as 7 exponent x times 1, since x times 1 is the same as x. All right. All right, so this is what we have. Now, the next thing we are going to say or do, okay, is that we can say anything over itself is 1, okay? So we can write 1 as 2 over 2. Since 2 over 2 give us 1. So our equation becomes 7 exponent x times 2 over 2 minus 2 exponent x all squared equals 33. All right, so we can expand this exponent. So we can write it as x times half times 2. Okay? All right. So our equation becomes, okay, 7 exponent x over 2 times 2 minus 2 exponent x squared equals 33. All right, so this is what we have. Now let's apply the power of a power rule here, okay? Now a exponent m times c is also the same as, okay, a exponent m multiplying the exponent c. So we're going to have 7 exponent x over 2 squared minus 2 exponent x squared equals 33. All right, so this is what we have. So we say let 7 exponent x over 2, okay, let 7 exponent x over 2 exponent x over 2 stand for a, and let 2 exponent x stand or represent b. So you're going to have a squared minus b squared equals 33. All right, so let's apply difference of two squares. So we say a squared minus b squared should give us a plus b times a minus b. So our equation becomes a plus b times a minus b equals 33. All right, now 33 is the same as 11 times 5, okay? It's also the same as, okay, 33 is the same as 5 times 11. Now let's use these two cases, okay? You can try for other cases and see if they work. They will work. All right, now by inspection or using inspection, you can see a plus b, okay, the first part of the binomial is greater than, okay, a minus b. Because of that, this is rejected, okay, because it's not going to give us what we are looking for. So you're going to have a plus b times a minus b equals 11 times 5, okay? All right, equals 11 times 5. All right, so we can say a plus b equals 11. Let's call this equation 1. And we can say a minus b equals 5. Let's call this equation 2. All right, so let's use the method of substitution or elimination to solve the problem. So here we're going to use elimination, okay? So we say let's add equation 1 and 2, okay? So you have a plus b equals 11 plus a minus b equals 5. So you are adding the two equations. So you're going to have 2a equals 11 plus 5. That's 16. Okay, let's check. 11 times 3 rather. Okay, so you have 11 times 3. Okay, so this is 11 times 3. 11 times 3. 11 times 3. Okay, 11 times 3. All right, so equation becomes 2a equals 14. Okay, so 2a equals 14. Let's divide here by 2, here by 2. So 2 goes here, 7. So a equals 7. All right, now we said, okay, let a, but a stands for, okay, a stands for, okay, 7 exponent x over 2. Okay, now we used, let's check something here. So you can see here, we said let 7 exponent x over 2 be a. So a stands for 7 over 2. And let 2 exponent s equals b. So whether you use b or you use a, you can find the value for x. And we are looking for only one value for x. So we can use either b or a to find x. Okay. So we say, okay, a equals 7 exponent x over 2. Therefore, we can say 7 exponent x over 2 equals 7. Okay, 7 exponent x over 2 equals, now 7 is the same as 7 exponent 1. Okay, at this point, we can say x over 2 equals 1. Okay, you can see when you apply the one-to-one property of exponential functions, when the bases are the same, we can equate the exponents. Okay, all right, in this case. So you're going to have x equals 2 times 1. Therefore, x equals 2. Now let's check and see if x satisfies the equation. So we have 7x minus 4 exponent x equals 33. So we're going to have 7 squared minus 4 squared equals 33. Now 7 squared is 49. Okay, 4 squared is 16. All right, let's do the subtraction. So you have 49 minus 16. So this gives us 3. This gives us 3. Okay, so you can see the equation is clearly satisfied.